And next, we'll continue on with United Aircraft Technologies.
We live in an age where most people have experienced flight. However, not many are aware of the time and money it takes to put a plane in the air. American Airlines, for example, owns over 200 Boeing 737s and spends tens of thousands of hours maintaining the 30 miles of wiring being held within. Wiring that is currently held in place by around 20,000 metallic clamps. But what if there was a better way? Imagine no longer wondering what's behind these soundproofing panels, doing wiring inspections in minutes instead of days, getting a prescription based on data and algorithms telling you what the problem is, how to fix it, and where it is located. Imagine the thousands of hours and millions of dollars that can be saved if a system existed that gave you the real-time status of the electrical wiring. My name is Abigail Rising, and I am the CEO of United Aircraft Technologies, UAT. And we are reimagining electrical wiring management with our sensing clamp system that reduces weight, minimizes operational costs, and improves maintenance through augmented reality and artificial intelligence. How do we know? UAT was created based on the life experience of a US veteran, Darian, who was an aircraft electrician for the US military for over 14 years. Due to repetitive strain injuries from installing the metal clamps used in today's aircraft, Darian's career was ultimately cut short. Although he had lost his job and his home, Darian turned his hardship into hope and became an engineer to create the solution. With his technology and my experience as a successful entrepreneur with a prior exit, we created UAT. Together we lead a team of engineers and business professionals with backgrounds at Boeing, Lockheed Martin, the US Air Force, the US Navy, and even NASA. Our lead aerospace engineer, Gerardo, has over 30 years of experience working for IBM, GlobalFoundries. Our lead software engineer, Rocky, has worked on prior successful projects similar to this with Lockheed Martin and NASA. The team also consists of a group of retired military directors such as Valerie L. Muck from the US Air Force, Emily Harmon from the US Navy, and multiple officers from the US Army who guide us on our path towards commercialization. This age of aerospace innovation and revolution is leading to incredible achievements in engineering. However, this comes with increasingly complex electrical systems, and we must innovate the way we monitor and manage them. Equipment has been developed to minimize aircraft downtime and reduce operational costs of the biggest component in an aircraft, the airframe. However, not much monitoring, if any, exists for the second biggest component, the wiring. For that reason, UAT has reimagined electrical wiring management and created the smart interconnecting clamps that can replace the inefficient clamps of today. UAT's patented interconnecting clamp system for aerospace wire harness management replaces the legacy metal design with a new ergonomic and considerably lighter resilient thermoplastic alternative. This is not just a clamp, but a smart clamping system with an embedded network of sensors that can map, monitor, and diagnose faults in the electrical system of any vehicle imaginable. It measures amperage, EMI, temperature, and other variables all wirelessly and without the need of batteries. You simply place the clamp, assign it its location, and you are ready to begin monitoring the electrical systems thanks to our algorithms and preloaded thresholds. The smart clamp combined with our augmented reality monitoring system uses artificial intelligence to create a live digital twin of the entire electrical system. This digital twin guides the crew in localizing, diagnosing, and troubleshooting its electrical problem, thus improving fault diagnostics by over 150% and minimizing the reliance of visual inspection and risks of human error. Crews no longer need volumes of manuals and days of labor to troubleshoot electrical problems. UAT provides the status of the entire electrical wiring system in real time in the palm of your hand, reducing troubleshooting that takes days or weeks down to hours with a few simple steps. Our unique design also avoids additional metallic installation hardware, making our products 65% lighter than the current metal clamp. If you were to replace 15,000 to 30,000 of these clamps in an aircraft with ours, the total weight of a commercial aircraft that can be reduced is by over 600 pounds or 800 pounds or more from a spacecraft. Let's look in more detail on how our smart interconnecting clamp system can reduce weight in current spacecraft. A NASA launch costs an estimated $10,000 per pound of payload, and with 50,000 pounds of total payload, that one launch costs $500 million. Our clamps will remove 1,700 pounds from the total weight of the spacecraft, saving NASA $17 million per launch in weight alone. Keep in mind that these savings will be in addition to the hundreds of hours of maintenance and labor saved by our system's ability to see directly into the problem areas in the electrical system. This technology could also go beyond rockets with potential uses in the International Space Station. Currently, in the event of an electrical malfunction or during routine maintenance, our astronauts will be required to troubleshoot or monitor complex wiring bundles and electrical systems, using up hours looking through manuals and navigating what's behind the panels. In a situation like this, our smart interconnecting clamp system, in tandem with our augmented reality monitoring system, will illustrate the map of the entire electrical wiring and integrate the hundreds of pages of information into a user-friendly representation. For example, in the case of a malfunction, it will be able to identify the fault, providing our astronauts with the additional time needed to address the malfunction and saving hours of their time so they can focus back on the main mission they went into space for. At UAT, we have strived to be the leader in both weight-saving capabilities of our clamps as well as the resilience of our materials, capable of surviving extreme environments, setting UAT's clamps above other thermoplastic and metallic fasteners currently available. We have also worked on being one of the best solutions for wiring troubleshooting and diagnostics. While currently a process called time domain reflectometry is used to detect impedance changes in electrical wiring, this process, however, requires the aircraft to be grounded, and it can detect the exact location of a fault down to the wire. Unlike our smart clamps, in tandem with our augmented reality monitoring system, which can provide the live monitoring on the ground and in the air. The commercial opportunity for our clamp is substantial. As an example, let's revisit the 737. Pre-pandemic, Boeing made 52 737s per month, each having 20,000 fasteners and clamps. That's over 1 million units a month, just for one model in one market. Take into consideration the many applications of this technology in the electrical grid, all forms of ground transportation, watercraft, and even the potential market in spacecraft. Therefore, we estimate that UAT has a $16 billion market opportunity. We've also made substantial progress in our commercialization process. We work with multiple manufacturers such as Lockheed Martin, Bell Helicopters, and Boeing on their modernization projects such as the Future Vertical Lift, which is aiming to replace the current legacy aircraft with far superior and efficient rotorcraft, where UAT has the opportunity to be part of this growing fleet for decades to come. Due to our performance track record and results in a short period of time, we've already obtained over $1 million in contracts through the Future Vertical Lift initiative in the US Army, as well as through the US Air Force contracts. And we are on track to surpass it this year. Additionally, we've recently closed a $1.5 million round of funding coming from investors that were prior officers in aviation in the military and commercial sectors. We are set to launch our non-sensing model in 2021 and our sensing model in 2022, which is currently on a tier level 6. We understand the high-quality performance necessary for aerospace, which is why we have tested it on the rigorous military specifications and have passed thus far. We've also established our manufacturing facility, which is ISO 9000 compliant and capable of producing up to 1 million units with space to grow. Currently, we're looking for collaborations so we can continue to apply our technology to the aerospace market and opportunities to showcase what we can do. Our mission is to create the modern standard of electrical wiring management and maintenance. Anywhere there is wiring, we plan to modernize it. Perhaps UAT can be the monitoring tool for future space hubs and settlements. Let us work together and reimagine electrical wiring management as we know it. See you there.
All right, thank you. Let's start off with some questions. Alex.
Hi, thank you. That was a great presentation. I have a few questions about the augmented reality aspect here. So you mentioned that you can then walk through and you showed a graphic of a helicopter and you sort of had a map of the wiring and your clamps in there. How do you build that model? Like how do you go and you set how does the system know where each clamp is? And do you need to do that uniquely for each different type of vehicle that you're going to be working with? Or is there an automated way of doing that?
Certainly, thank you for your question. So at the beginning, when we first started building, we did this by mapping the electrical wiring. This is done by the manufacturer giving us the schematics, which they already have built, and we put it into our system, or it comes with us actually going and scanning the electrical wiring in the aircraft. But we have created a way for automating the process of laying out the wires, so the wires are laid out automatically once we continue gathering the data as electrical wiring performs and where they're located in different systems.
Okay, thank you. Can you say a little more about how that works?
Certainly, some of it is a little bit of more of a proprietary that would be more than happy to speak with you separately. But it is basically thresholds and not thresholds, systems and algorithms that we set in place. Is a program software that will be able to go through, and each clamp has a localization for each system that helps feed into the information, which I will be more than happy to go into bigger depths with you separately.
Okay, thank you.
Bruce Yost, do you have a question?
I do. So how is there a lower limit on how small the clamps can be? And the reason for my question is do you really even need a clamp to do the sensing? Because if you could do the sensing somehow, that's very I think very powerful, very useful, especially I'm thinking of course for spacecraft. But so how small can you go?
Excellent question. We actually can go as small as for a single wire. Currently, there are 63 different sizes of clamps in it that are in the market. We fit all those 63 sizes, so even the smallest wire. And to answer your question, can we do it without the clamps? Yes, we can do it without the clamps. However, we also, with our clamps, we add the additional layer of being safe because one is thermoplastic and two is significantly lighter than others, helping save weight. Even if it's small, saving some weight around it. But yes, to answer your question, it is capable of.
Thank you.
John Dankenich.
Yes, so that was a great pitch with clear key performance parameters for mass reduction. I'm wondering though, can you comment on what fraction of aircraft maintenance costs and failures are related to wire management and or degradation that you'd be monitoring?
Excellent. Yes. So I'll use the U.S. Navy as an example, which has some data that are out there. Currently, they spend around 4 million hours just doing electrical maintenance, and the biggest reasons why this happens is intermittent faults that happen on the air that cannot be reproduced on ground. And this is due to the degradation of the insulation of the wiring. So as wiring ages, due to vibration, exposure to the environments and different chemicals, the wire degradation begins to fail and begins to cause this intermittent faults that you cannot see visually. And with time domain reflectometry, you can't detect either. But with our clamps, you'll be able to detect it. In regards to the amount of parameters of things that we can detect, we actually detect over 22 different instances, going from corona, the corona effect that can happen, lower pressures, going to the wire degradation, as well as changes if there's a kink in the wire, if there's a resistance. We're able to measure all of that, which I can also showcase later on the full list of all the faults that we can detect.
All right, thank you.
Zach Ellis, do you have a question?
Yes, I do. Hi. So I'm curious, what's been your biggest technical challenge thus far?
Certainly. The biggest technical challenge, I will mention two. One is on the technical side, one is on the more the commercial side. But the technical side was to go as small as possible. So for us, we want to maintain that weight saving capability with the sensing clamp. So we were able to partner with the SUNY Polytech Nanoscale of Engineering Institute, and we were able to scale down our biggest component down to the minute size, which is around 1 gram of weight. That was the biggest technical challenge that we had, scalability and size. And when in regards to the top of the commercial side, the other challenge was because we want to be the standard side, we will be above and beyond when it comes to performance in the harsh environments. Our materials, the way that we use both the external clamp as well as the cushion inside, are one of the best that are currently in the market. And the biggest difficulty was, one, to secure that supplier, and two, to make sure that those two bonds. And so we were able to thankfully do that as well. Actually, earlier this year, we're very happy to do so.
One more follow-up, if I could.
Yes.
So you figure a typical clamp may have any number of wires going through it.
Yeah.
How do you pinpoint which wire's having the issue? If it's one of 10, one of 6, one of 3, how do you know which wire's having the issue?
Sure. That's a part of the proprietary side as well. We have an algorithm separate, but I will do a brief explanation. So because we're monitoring the magnetic field going through the electrical wiring, each wire that goes through has its own signal, its own frequency. And because our clamps have already established those thresholds, we're able to do a comparison, be able to tell which wire specifically is having the problems. I can tell a little bit more further on specifically how we do that, a little bit off the
Okay.
public sector.
Thank you. I appreciate it.
No problem.
Great. Greg, you have a question?
I do, and good morning. Boy, I wish we had this innovation many, many years ago, because the space shuttle for many months was grounded because they had to trace a lot of wiring issues within the orbiter, and it was all custom harnesses and the like.
Yes.
So this is a cool idea. My question is how your AI system, can it detect different types of issues? Meaning, can it distinguish between a nick, a worn insulation, a bent pin, a stretched cable, or is it just pinpoint what the cable of issue is? I was trying to, how much it does in the troubleshooting aspect of it as well.
Certainly. So we built a suite of algorithms to be able to detect, because each type of malfunction operates differently and has different telltale signs that go beyond just, oh, there's a loss of amperage or there's a spike of amperage here. So the reason why we call it a sensor network is because while I presented on the presentation a few of the sensors that we have, these other sensors that are in our clamp, you are using tandem to what is being isolated, and we'll be able to tell, for example, that the temperature spike or the temperature decrease will be able to remove a lot of redundancy and be able to give us more of an accurate diagnostics. Granted, as the more the clamp performs, as the more the data it gathers, the more accurate, the better we'll be at doing diagnostics. But to answer your question, it is by studying the way the temperature, humidity, and all the different types of performances changes, depending if it's a nick, if it's a stretch pin, or a bent pin. That's how we are able to monitor the do those diagnostics. Did that answer your question?
Yes, just a quick follow-on. You would envision learning more as you get more experience and more data points on your sensors and different applications as to what could potentially be the particular issue with the wire that you could share with whoever's using your clamps, yes?
Exactly, and that is part of our business model. It's not only just to monitor, but it's also to learn how wiring works. Because currently, while we understand vibration chemical has an impact on the degradation of the wiring, we don't truly understand the full spectrum of what affects wiring and depth as it operates over a long period of time. And we want to do what the HUMS, or the Health Users Monitoring System, has done for the structure of an aircraft, for the electrical wiring, to be able to study across time and use all that data points to be able to help with both the layout and design of the electrical wiring, but also the performance of the wiring across a long time period of time.
Thank you.
Chandra, you have a question?
Yes, great presentation. I have two questions. First, I don't see a patent secured with your company, so where are you guys in the IP process as well? Have you done testing with temperature and vibration on this? And as well, could this be used for computer networks?
Thank you for your question. We got granted 2 of our patents. Very excited. One, we received the little piece of paper says patent, the very fancy one. I received it, I think, 2 weeks ago. So we have a patent on the utility of the clamp design, the fact it's hardware-less, so the weight savings. We also have a patent on the network of sensors and our algorithms that's been granted to issue. It's going to be issued, I think, in June. But besides that, we also have a PCT, and we have filed in Canada, Brazil, Europe, Arab Emirates, and South Korea for our sensing algorithms for the sensing clamp. In regards to the fact that we've done temperature and vibrations testing, we've done the temperatures, the 15 vertical flame, the 60 vertical flame, direct flame. We also done vibrations at 3,600 RPM for the period of around 1 hour to 8 hours with variations both lubricated and non-lubricated, which is around the type of vibration you can experience on a rotorcraft, which is kind of intense.
As well, can it be used for computer networks?
Yes, I just realized I was missing that. Yes, it can be used for computer networks to monitor the full breadth of what it's being used all across.
And sorry, I missed, were you able to test it in cold as well?
Yes.
Okay.
It is able to test in cold.
All right, thank you. Mark Walker.
Thank you, Abigail. So just following up on the question about the patents and the protections, what is the competitive landscape like? There must be quite a number of manufacturers of clamps that are looking to target the similar market. I'm most interested in the sensing model.
Sure. I'll address briefly the base model, and then I'll go towards the sensing model. For the base model, there are the standard metal clamps, which have been used since the 40s, 50s, that are still being used. And then for the thermoplastics, there's other company that makes a thermoplastic clamp for aerospace. However, this company still requires a lot of metal hardware, and they have not been to be able to yet enter the military space because the weight savings are not as significant to be able to enter this space, as well as the cushioning is not as comparable to ours. On the second hand, for the sensing, time domain reflectometry is the closest technology that we have when it comes to monitoring the wiring system. And to that, like I mentioned, the problem with this is it requires the aircraft to be grounded for a signal to go through. It will be able to tell you around some of the surrounding what the problem is, but it cannot tell you what it is, cannot monitor on the air, and it cannot monitor the degradation of the insulation. Because sometimes a lot of the intermittent falls or small amperage leaks that begin to happen is due to degradation of the insulation. And this, because the copper wire has not been affected, will be able to tell you everything's good. And so that's when it comes to comparing landscape for the sensing. So far from all the information and all the research we've done, we have not been able to find a fastener that does sensing and monitoring in situ wirelessly for electrical wiring.
All right, thank you. One last question, Ramona?
Yes, mine is more space-oriented environmental conditions. Radiation's known to impact wiring negatively, so there is an interest there. I'm wondering about, have you tested your system for the impact of the kinds of radiation that one may experience in space, and how that would negatively impact your system and both your clamps and the other hardware?
Excellent question. We've been able to test our base model materials for the different types of radiation because we do include a radiation sensor. Like you said, it does affect the electrical wiring. We have not yet been able to test the full system yet on the radiation levels that we do be able to experience. Oh my gosh, Spanish is coming through. You'll be able to experience in space. And that's why we're looking collaboration with NASA and other organizations for us to be able to achieve this. But we have to the equipment that we have accessible to us, we'll be able to test for vacuum for the different type of radiations, but not to that level yet.
Thank you.
Any other questions? We have time for one quick one. All right.
I have one, Abigail. you mentioned the weight savings, and I'm curious to know actually if that's metal clamp to thermoplastic clamp, or if that includes presumably you also have data systems or power systems or auxiliary systems that are required in order to process the data. Does your weight savings take into account system level weight savings?
It does. It does, because we don't require any external power units or any computer on board to be able to operate. So it does account for that as well.
All right. Thank you very much, UAT.
Thank you. Thank you all for your questions.